The Lasso Method for Multi-Robot Foraging. We propose a new algorithm for multi-robot foraging. The robots are guided by a scalar field to circumnavigate the environment, bringing objects in towards the goal. This shows this scalar field and highlights the goal position. Unlike most foraging methods, ours handles the case of an arbitrary boundary. How do we define the scalar field? We process an overhead image of the environment, and we need the concept of travel time. Consider a wavefront emanating out from the goal. The travel time is the time at which this wavefront reaches position X in the environment. We compute the travel time from the goal with wavefront speed given as distance from the boundary, and this yields the scalar field. The robot control algorithm has 3 steps. First is to choose an isoline of the scalar field. In this case, the isoline value is 0.45. Then we apply a control law to follow this isoline. And then we apply collision avoidance and some unsticking behavior. This shows real-world trials of this method using overhead camera and April tags on the robots for localization. In this case, we can see that the system completes more quickly with 8 robots than with 4. We can further explore the number of robots in simulation. The robots that are highlighted in fuchsia are in a slowed state. And we can see that once again, 8 robots performs optimally amongst this set of possible robot numbers. We can also study the boundary complexity. In this case, on the left, there are no walls. In the middle, there are 2 walls. And on the right, there are 3 walls. Increased boundary complexity clearly slows progress, but the task can still be completed if we wait long enough. To conclude, we presented a simple way for multiple robots to gather items in complex environments. We can provide the scalar field through some localization infrastructure like an overhead camera, or we can actually sense the scalar field more directly. In future work, the intention is to address the requirement for a contiguous boundary and to compare with conventional 2-stage foraging.